So we are going to start with ARMA 1.1. Our standard notation for the ARMA side could be used YC plus phi1 YT minus 1, or did we use YT minus phi1 YT minus?
You use plus.
Plus, okay, good. Of course, it's not a big deal, right? Yeah. Even if you have minus, you can just reparameterize and not freak out like Alex.
I will freak out anytime. Do not come to me.
So YT plus B1 multiplied by YT minus 1. On that side, I will have epsilon t plus theta 1 epsilon t minus 1. Good. This is what I want you to do. Write both sides in terms of the backwards operator and tell me what uppercase V of B is and uppercase theta of B is.
I think you overestimate our capabilities, but we will try.
Sounds like a bunch of wires, like just being creative.
We're just trying to
We're just trying to maybe have like a three.
So YT plus P1 multiplied by B and YT. Theta 1 B epsilon T. So YT one plus P1 B equals one plus theta 1 B, right? So let's start with uppercase pi of B. So YT times 1 plus P1 B divided by 1 plus theta 1 B would be epsilon T. And I would like to somehow write 1 over 1 plus theta 1 B as an infinite series. We could write that as a geometric series, but we've got to make a minor adjustment because the infinite sum of a geometric series is 1 minus something. 1 minus the ratio term. So I can write it as 1 minus of minus theta 1 B. And that would equal to epsilon T. Yes?
How would you
So I will have 1 plus phi1 B multiplied by the series 1 plus minus theta 1 B squared plus minus theta 1 B cubed plus minus theta 1 B raised 4. I think we should be able to recognize the pattern with these, but let me go ahead and do one more time. Yes.
Why is it negative phi? Wouldn't it be
No, because you're subtracting a negative, which is positive.
So the infinite sum of a geometric series is 1 over 1 minus a.
Okay.
1 over 1 minus a can be written as 1 plus a squared plus a cubed and dot dot dot, right? I have plus. So if I take a minus out, I can write it as minus of minus h1b. That would be a now. So if that is a, I now have 1, oh, I missed a term. Plus minus theta 1b, which is 1 plus a squared, a cubed, a raised 4, a raised 5.
Yeah, I was just confused with the minus in front of the P1, so I just kind of thought that it would, you know.
Yeah, I'm trying to rewrite this so that I can use the standard identity that we have. So, yt times 1 plus v1b multiplied by 1 minus theta 1b plus theta 1 squared b squared minus theta 1 cubed b cubed plus theta 1 raised 4 x raised 4 minus theta 1 raised 5. Keep saying beta, I meant to say b.
We get what you mean though.
Good. A little bit of work is required. So I'm just going to distribute. So I will have 1 times all of those. So 1 minus theta 1b plus theta 1 squared b squared minus theta 1 cubed b raised 3, not beta, it's b, plus theta 1 raised 4, b raised 4, minus theta 1 raised 5, b raised 5. And of course, it's going to keep on going. So I'll just put dot dot dot. Good. Next, I am going to distribute v1b into the second expression. Okay. So, more fun. v1b distributes in. So we'll have v1b minus v1 theta 1 b squared plus v1 theta 1 squared b cubed minus v1 theta 1 cubed b raised 4 plus v1 theta 1 raised 4 b raised 5. Good enough, because I've got up to b raised 5, so dot dot dot. So that was equal to epsilon t. We're going to combine like terms. So yt 1. So I have negative theta 1b, phi1b. Combine those two together. I'll have phi1 minus theta 1 b. Yes? For the b squared term, I have phi1 theta 1 multiplied by theta 1 squared. Yes? For the B cubed term, I have phi 1 theta 1 squared minus theta 1 cubed times B cubed.
Why is it switched up this time around?
Over here.
So it's two what b squared is.
Is it theta 1 cubed?
I just unsure as to why it's switched.
So it's minus and that's plus. So I'm keeping the first term to be positive.
Yeah, I'm sorry, I was just having a bit of trouble connecting.
Yeah, when I do the general term, it makes sense. So all I'm trying to do is keep that first term positive for now. Theta 1 raised 4 minus phi 1 theta 1 cubed b raised 4. Lastly, phi 1 theta 1 raised 4 minus theta 1 raised 5 b raised 5 dot 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 equals epsilon t.
This is why we have computers to do this.
So
Well, to be fair, a lot of people not, I'll touch this, they literally have.
if you recall from last time and today, an AR infinity series is y multiplied by uppercase I of b. We took this last time, yes.
I did test, but I think so.
So y multiplied by, how did we write this last time? The uppercase pi of b.
Did you end up
The I with the circle.
The beta. So pi of b is simply 1 plus pi 1 b plus pi 2 b squared pi 3 b raised 3 pi 4 b raised 5 pi 5 oops 4. Infinity, right? And as we talked about multiple times, the very first coefficient pi 0 is 1. Just like the sine rate psi 0 equals 1. Now, look at this expression and look at that expression. By direct comparison, we can find out the values of heights. Do you agree?
That's more.
Look at this. Look at this. Is it possible to solve for pi 1, pi 2, pi 3, pi 4, pi 5?
Yeah, I mean, wouldn't pi one just be the phi one minus theta one? I don't know.
By direct comparison, pi 1 is phi 1 minus theta 1. Pi 2 is theta 1 squared minus phi 1 to 1. Pi 3 is phi 1 theta 1 squared minus theta 1 cubed. Pi 4 is theta 1 raised 4 minus phi 1 theta 1 cubed. Pi 5 is pi 1 theta 1 raised 4 minus theta 1 raised 5. Good. And of course I could put a dot dot dot. If we have an invertible process, these pi weights must satisfy one condition. And what is that one condition?
The denominator is not 0.
Great. When we derive the theta polynomial, must have roots that lie outside the unit circle, great. And if that happens, the pies would satisfy a certain property, even if it is an alternating series.
I'm gonna state yes, absolute example.
They have to be absolutely summable. If they're absolutely summable, then you would end up having a finite value in the sense the pi values would converge. Now, just for fun, I'm going to rewrite this as minus theta 1. Or pull the minus out, write it as P1, excuse me, theta 1 minus theta 1. Of course, I can do without this, but I'll get a pattern that is easier, I guess. If I pull theta 1 out of second term, what would I get? Theta 1 minus theta 1.
Like magic.
Yes. Let's see, that's minus. I want this to be plus. So pull a negative out. I will have minus theta 1 times phi1 minus theta 1. Good. But phi1 minus theta 1 is pi 1. Do you agree?
Yes.
Going to replace this minus theta 1 pi 1. Good. Going to pull theta 1 squared out. If I pull theta 1 squared out, I would have phi 1 minus theta 1. Correct?
Which is pi 1 again, right?
Which would simply be theta 1 squared times pi 1. Yes? But I can also write it in a different way. If I kept this as minus theta 1 times minus theta 1, phi 1 minus theta 1. Correct? What is that term?
That is pi 2.
That's pi 2. Good. Pi 4, if I pull theta 1 cubed out, I would end up having theta 1 minus phi 1. Which will give us minus theta 1 cubed. If I pull the negative out, phi 1 minus theta 1. Yes? And phi 1 minus theta 1 is simply pi 1. With me? So we can leave it as is, or write it as minus theta 1 times theta 1 squared multiplied by phi 1 minus theta 1. Correct? Well, what is theta 1 squared times phi 1 minus theta 1? It's simply phi 3, excuse me, pi 3. So you'll have negative theta 1 times pi 3. Good. I want you to try, I mean, you should know the pattern by now. So, what is pi 5?
Minus theta 1 pi 3.
Is it minus or negative? Okay. Correct.
Wait. No, shouldn't that be? That should be positive.
Why?
Oh, wait, no, never mind, that's okay, something else.
If we just simply look at the pi 1 values, I can write in general pi k plus 1 is minus theta 1 times pi k. Correct? For k greater than or equal or greater than 1. When k is equal to 1, we would have phi 1 minus theta 1. Nice little recursion, right? So we can easily program this. Equation. We can also write it in terms of the theta expressions that we see in terms of pi 1 directly. So if you look at pi 2 was theta 1, pi 1 with the negative. Yes? Correct. And pi 3 is theta 1 squared, pi 1. Pi 4 is negative theta 1 cubed, pi 1. So what is pi 5 then? So we have our usual pi 1, phi 1 minus theta 1. Pi 2 is negative theta 1 pi 1. Pi 3 is negative, theta 1 squared pi 1. Pi 4 negative theta 1 cubed pi 1. What is pi 5?
I think you mixed it up on the, is it supposed to be pi 1 or pi 3 for pi 4?
No, he's leaving it as a pi 1.
See, I'm using,
Oh, okay, you're trying to guess pi.
I'm using the pi 1. So this is a recursion where pi k plus 1 will depend on the previous pi k. But over here, I'm trying to have the pi weight in terms of the very first one. So what is the next step?
Pi 1 to the 4th power or no, wait, no, theta 1 to the 4th power times I1.
right?
Yeah.
Dot, dot, dot. In general, pi k will be equal to, how would we write this? So, as a recursion, we can write this as pi k equals theta 1 raised k minus 1 minus 1 raised k minus 1 times theta 1 raised k minus 1 pi 1. Right? I can combine it and put it under 1 power minus theta 1 raised k minus 1. Okay, greater than 1.